So first off, I guess this is kind of the theme here, because I don't know much Ruby really. So I do know a bit about type checking and type systems in different ways, and I guess you know Ruby. So together, perhaps somewhere in the middle, we can figure this thing out. So if you have any questions or like, can you try this thing or can you do this thing, then just raise your hand or say it and we'll try. So interactive. Because I don't know, and don't laugh about my Ruby code because it will probably look funny. So yeah, there's this RDL thing. You can find it on GitHub as usual. Yeah, they have a lot of stuff here. I'll go through some of these things. But yeah, let's jump into it directly. So as I said, my goal was to type some existing code, not to like if I were to write a new system and I wanted a type system for it or type checking, I would probably just use Haskell in the first place. But if you have some existing code and you want to make it more safe to change it, maybe this is a good choice. So what you do is basically if we have this, I have some example module here, and I've imported RDL stuff. Yeah, I'm not sure about those two second imports, but they need to be there for some reason. And then you extend this annotate. Is that a mixin? No. No, yeah. You get these things in scope in the static kind of class context. Anyway, so let's say we wanted to write a function called inker, and I wanted to be like a class static thing. So let's see. Huh? Yeah, this is not an instance method, but yeah, like a function. Yeah. So I want this to do the simple thing. Okay, cool. Regular Ruby so far. Yeah, and we want to type check this so that we know what's going on. So then I can write type, which is an RDL thing. And then you provide a string with the type signature. So there's no like Ruby DSL for the types, but you write them in a string. And then you, inside parentheses, you put the arguments for the function. And then an arrow, and then the return type. So this is a function from one integer to another. Okay, and so far nothing much is happening. So this, I think RDL, as I've understood it, it takes a different approach to many of these like external type checkers. Or so what it does, it runs at runtime with Ruby. It's not like an external thing which parses all the Ruby code and tries to figure out what's going on. It actually, when this file is loaded by Ruby, it does some things, but you can kind of configure what's supposed to happen when it loads the code. So right now it just registers this type for the RDL kind of registry and says like, whenever you need to figure out what the type of inquiry is, I know that for later. It won't do any checking of that body so far. So what we can do to actually get some checking of that body is to say type check now, which means it will do the type check when it loads this code. Okay, and to start to play with this, I've defined a test for it. So I have one RSpec test which just calls do type check, it's called. So let's start that in a little watcher thingy. So we will see, yeah, it type checks and it's cool. What we can do now is to break this, just to convince you that it's actually working. And we're at Foo Café, so like this, and we see long error here. This is the interesting part. Okay, what does it say? Static type error, got type string, where return type integer expected. Okay. Hey, welcome. Okay. So I'll get the errors inside here also. So I'll maybe not do the scrolling thing all the time, but we'll see. So foo plus x plus 1, like this. we get a new error, and it says, oh, it's too small. It's a bit sad. I'll do the scrolling then. Okay, what does it say? Argument type error for instance method string plus. Okay, so it says that if you use plus on strings, it's supposed to take another string and return a string, but you have given it an integer instead. So it knows about these things for the kind of built-in stuff. That's, I guess, what we get with types core, I think. Yeah. Yep. On this. Okay, like this. What is it to I, right? Still sad. Yeah, same thing. So it actually, it doesn't only check the whole expression, but the sub-expressions and everything. Okay, let's see. We go back here to where it's happy. I'll just see where I'm supposed to say. Yeah, okay, so we use this now thing. So it type checks as it loads this code. What we also can use, I showed you not doing any type checking at all. Then if we do this, we say to RDL, the type of this function is integer to integer, trust me, right? Don't ever bother trying to do some kind of static checking of that. Yeah, and also for other functions using this, because if they are type checked, you can kind of end the type checking here by saying, like, if I'll show you in a short while, but I can have another function calling this, which is type checked, but this is not. So you can use this to type check things that you haven't defined, maybe, or that you, yeah, external things, like you said. If there is something in Ruby which the RDL people forgot to add a type annotation for, you can just say, like, this explicit, you know, fully qualified thing over there has this type. Kind of like that. But okay, what you also can do is to say type check later. And this is a bit confusing at first, but it doesn't type check when it loads this code. It won't go through the body at load time, but instead when you call this do type check, and then it's already collected all the things. And this is useful in this case where, let's see, we'll extend this or keep the later thing going, or I'll keep the now. So let's say we had another function called add, taking x and y, doing x and y like this, okay, and then we'll use it here instead. Say, I don't know if you can write it differently, but we'll add x and 1. First we will get an error saying no type information for class singleton method add, because we hadn't provided any signature for that one. So we'll say here, this is a function from 2 integers to 1 integer, and just trust me. Okay, but we still have this error, no type information. Why do you think that is? It's kind of subtle, but what's going on here is that, like, as it loads these things and interprets these things, it will do the type checking. So when it comes here, it hasn't yet seen this type annotation. So what you can do is defer the type checking to after. You can, you can. I'll show you a bunch of different solutions, but you can say later, and then okay, fine. It'll do it when I run RSpec or this plugin thing I have. Or as Ola said, you can put it here. That's okay. Or if you have it down there, you can put all the type signatures in the top, but then you have to say what they apply to. So you can do like self add. This is also fine. So you can keep them in a separate file or yeah, whatever. Let's go back here. So yeah, that's the thing with later, basically. What's going on there? Okay. What have we got? Yeah, okay. So I'll fix this thing by using later for now. So let's say you actually want to run your code at some point. We'll require the example file and then do example, let's see, which one? Inker. Okay, what do you think will happen? Just add some stuff. Very nice. Okay. What do you think will happen? Yes. Somewhere up here, it does the same type checking at runtime as it would try to do at compile time, basically. Okay. Let's try. I don't even know how to. Okay. Oh, like this. Oh, that's cool. Okay, and last question. No, not last, but this one then. Oh, sorry. Type error, yeah. Yep. Okay. Last one. Type error? No! It's not a type error. It's a, where is it? No, wrong one. Here. Undefined method. Not again. This was the point. Oh, no. Skånetrafiken. Please go away. Yeah, so this is not what we wanted, right? We wanted cool type checking, not nil errors. But what we can do is to put these angry bangs everywhere. Must be a non-nillable integer. So it kind of defaults to this type or nil if you don't use these bangs. And I think one reason for that is that there are special corners of this where it can't prove that it's not nil, so it defaults to accepting nil. And then at runtime it might fail anyway. Like so, if you have some place in your code that is obviously nil, then it can statically see that this is nil, this is not okay, but it can't for all usages. But at runtime, obviously, it can check for nil. So I'll restart this and require. And now we get the type error again. And this is nice because if this type error would happen like 5 functions down somewhere, it would be really hard to figure out where it started going wrong in a way. But now we get the type error early or at the kind of local place where it makes sense. Yeah. Okay. No. So like if we called if it this is horrible. Let me disable Wi-Fi. There are buses passing, so might be that. Okay, so maybe not Inker is a good example in that case, but like render my HTML maybe. Like and I have a lot of function calls in that, and it ends up calling some template language, which produces a empty string in the template where I really wanted something because I passed nil. It would be really hard to figure out that it was because I had nil up there that I got the empty template result over here. And then you get the nil pointer where it's the error for nil where the contract kind of says so. So that's the you don't get these spooky action at a distance nil things basically. Okay, so that was nil. Okay, so in my example, I can just show you a slightly more complicated thing. So what I wanted to do in the work situation was to basically we had it calculates a big tree structure of scores for a company for a bunch of rules, and different indicators in this tree can be either bonus indicators or regular indicators, and then you consider these points as different things. So you can either get regular points and bonus points, and the regular points is what you try to, there's like a target, you want to get up to a certain level of regular points, and then you can also get the bonus points, which aren't required, but like you can try. And these kind of bubble up and get aggregated. So you will at each level in this tree see, okay, so for all these indicators in this part of the tree, you will have these many this many points and this many bonus points. So it was, and you can see in this code that the bonus point concept came afterwards because it was really kind of bolted on, and a lot of manual summing everywhere and bugs and stuff. So I wanted to create like a class for points which held both kinds and summed them up correctly with some kind of algebraic behavior in a way. So I think that example might be good to show. So let's say we have a class point. Help me write this one because I'll probably fail. So we have a class point, and the constructor takes regular and bonus, right? And then what do we do? Regular, this is how you assign them, right? Cool. I'm not too far off. Okay, and we'll have like readers for these. This is not too bad, right? So we want this to be typed now. Then we can, okay, first off, in all these contexts you have to use the extend. So we'll add this one, and we can then say that we don't have to name it, sorry. We can just say that the type is, it takes one integer, again, integer, but then it returns self. So there's a special thing called self for instances. So if you have like inheritance and stuff, it will be this type. Which one? The self or the integers? They can't. Let's be good and enforce that. Yeah. So far so good. Let's type check this now. Failure. Why? No type for instance variable regular. Okay, so it also sees the methods and the members of the class, and it keeps track of classes quite well. So what we have here is both let's say instance variables or members, whatever you call them, and we have these readers, right, which are generated. So what we can do is, if we type the readers, we get the variables for free, basically. You might think like, why couldn't it figure this out from the arguments from this constructor? I don't know why it doesn't do that, but what you can do is say @reader type regular integer, and the same for bonus, I think, like so, and then it goes away. Cool. So now we have types for the accessors and variables. And I can show maybe some example, like if you wanted to do a plus of these, you would take some other point, right, and construct a new point where the regular points get summed up with the other regular points and the bonus ones with other bonus, something like this. And just to show you the self thing going on here, we would accept a self and return a self. And this, you always have to write this, as I understand it, type check now, but yeah, it's good. And if you want static things, you can do the self dot, yeah, that thing that I did up here. That works too. Yeah, this is basically it. There are a lot of other things in this library. So if you check this table of contents, you see a lot of stuff. Nominal types, they have like, I think there's the type called Boolean is an alias for a union type, which is true or false. So they have union types are like, I can say that this type is either a string or integer. So I can, oh, alarm time. So basically, I think it's a design decision because I guess Ruby programmers use Ruby quite flexible, like a flexible language that can do a lot of things, and like have dynamic behavior. If it's a string, I'll do this thing. If it's an integer, I'll do this other thing. And it wouldn't make sense to try to bolt on like Haskell or Java's type system to that. So they try to accommodate that with these unit types, as I've understood it. Yeah, but a lot of stuff like optional arguments and all that. I haven't checked like the dependent and higher order types yet. The structural types are quite nice. You can say that I want some value which has these accessors, I think, or like a hash with these keys at least and stuff like that. I found a bug where it seemingly couldn't handle hashes with string keys, only with symbol keys. It's called symbols, right? So yeah, there are some glitches, and there is supposedly, yeah, they have like finite hashes and open hashes and all that. Let's see what's more. A bunch of things around inheritance. Yeah, then there is supposed to be some kind of support for Rails, which is where this started breaking down for me. So I started using this in the context of the gem, which I was going to refactor. But the problem was that the Rails app was using the gem all over the place. So I needed to get the type checking into the Rails app to get any good use for it. And for some reason, we're still at Rails 3. Might be a problem. I don't know if they only support. It doesn't really say. I can't find anything at least. But it might be like they only support the latest version of Rails or something. So I tried for a good while to get this to run in Rails, but I couldn't. It just crashed. So eventually I gave up and I couldn't use this library, which was kind of sad because I got a lot of stuff working in the gem. Like I can maybe show you some just to get a sense of, here's this points thing. Like these are kind of simple, but let's see. It was calculated actual, no, lated actual. Like it could get quite complicated with the structural types, and there's also a thing called wrap. So you saw before when I used the console to call a function, it checked at runtime, like is this actually what you say, what it's supposed to be, and then you can disable that because it has some overhead. So for I think they've done this for library functions or like standard library functions in Ruby, because then just trust them to be correct. Yeah, so you can also use this dot here, which is kind of infer the type for me, and aliases, which are these percent some name. So I've used that for some things. Yeah, and also as you introduced, there's a thing called contracts, which I haven't said so much about, but you can specify pre and post conditions. I can perhaps show you quickly up here. So for some reason, say that we can only add 0 or greater numbers. So then you can say pre, and you can say that the x and y, let's see, x has to be greater or equal to 0, and y has to be greater or equal to 0. This should be correct, I hope. Oh, what happened? Have I done something weird? Receiver type integer not supported. Whoops. There's a thing. Uh, the thing we added to the classes, I think that's, you can't do that with classes for some reason, so let's remove that. Try again. Require. Now we're good. Okay, and okay, so the inker, no, the add one was it? We can add 2 numbers, but we can't add like negative numbers now. Yeah, then we get a contract error for these arguments, and you can use them for post conditions as well. Then you get the return value and the arguments, and then you can have like a invariant thing. The weird thing is that those are not type checked, so here you get a type error in the contract, which is kind of ironic, but yeah, I guess I'll put that as a bug report. But anyway, so you can use that as well. They are not enforced statically in any way. That's just a runtime thing, but might be handy. So to sum this little excursion up, I think this is an interesting project, but it's academic, it's really kind of rough edges, and the Rails thing was not so nice to go into. But maybe it works with newer versions of Rails. I don't know. They had like a disable Rails option. You can require some different version of RDL, which doesn't use Rails, I think, and you can also require a version of RDL where all these type things and pre and all that are just stubs, not doing anything. So if you wanted to disable RDL, like you have a gem which uses RDL and you want to use that gem, but you don't want to do type checking, then you can start by requiring the RDL/disable or something. So that's, I guess, one thing to note here, that this is like actual Ruby code running. It's not a type annotations in comments or something like that. It's something that you have to be valid Ruby at some point. So yeah, yeah, that's my experience with this RDL thing. So cool. Do you have any questions and like comments, anything? Yeah. 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 Okay. Yeah. Thanks. Cool. Any more? No, so I tried this last week for the refactoring stuff, but as it didn't work with the Rails thing, I had to remove it, unfortunately. So maybe someone else can get it to work, or in the future it will be more mature and usable. But I guess even if I would remove it afterwards, you could use it to guide your refactoring, even if it doesn't work at runtime later. But I'm not sure. I did get a lot of, while refactoring the gem, I got a lot of help from it, I should say. I got a lot of bugs and weird stuff also, but I guess like 50-50 help and 50-50 like busy work trying to figure out how this worked. So yeah, a bit mixed experience, but yeah, nothing in production. Okay, thanks. Thank you. Thanks.